chemical properties of metals. The first in that is reaction with oxygen. What happens when metals are burnt in air? And when something is burnt in air, it reacts with oxygen in the air. So general reaction is metal plus oxygen gives you metal oxide. For example, when copper is heated in air, it forms a black color copper oxide. Reaction is Cu, copper. When it is heated in air, it doesn't catch fire, but it produces black color copper oxide. To balance the reaction, we have to write 2 here and 2 here. So this copper 2 oxide is formed. Here copper is showing valency 2. It is also called cupric oxide, or nowadays it is called copper 2 oxide. Similarly, aluminium also forms a protective oxide layer. Now the formula for aluminium oxide, we know aluminium has a valency +3, whereas oxygen has -2. So if we do the crisscrossing, it gives us the formula Al2O3. To balance this, we have odd number of oxygen here. So first we have to make it even by writing 2 here. So we have 6 oxygen in all. So we have to write 3 here, and total 4 aluminium are there. 2 2s are 4. So 4 aluminium. So this is aluminium oxide layer. Now we know that generally metal oxides are basic in nature. So this aluminium oxide basic in nature. Similarly, if we burn magnesium ribbon in air, it will form magnesium oxide, which is also a basic oxide. Similarly, sodium oxide, then potassium oxide, calcium oxide, all these oxides, they are basic in nature. So all these basic oxides, they react with acids to give you salt and water. For example, magnesium oxide, if you react with hydrochloric acid, it will give you a salt, magnesium chloride, MgCl2 plus H2O, water. So 2 chlorine, 2 hydrogen, so 2 HCl. So this is nothing but a neutralization reaction. And here acid is reacting with a metal oxide, which is actually basic in nature. So basic oxide plus acid gives you salt and water. Now 2 oxides are exception to this, and they are zinc oxide and aluminium oxide. Zinc oxide and aluminium oxides are called amphoteric oxides. Zinc oxide and aluminium oxides, they are amphoteric. And meaning is that they can react with both acid and base to form salt and water. If we take the example of aluminium oxide and how aluminium oxide is amphoteric, first reaction we can write Al2O3, aluminium oxide. When it reacts with hydrochloric acid, it gives us AlCl3 plus 3H2O. So this is reaction of aluminium oxide with acid. But at the same time, aluminium oxide can react with a base like sodium hydroxide to give you a strange looking salt called sodium aluminate, having formula NaAlO2 plus H2O. Need to balance it, so there are 2 aluminium here, so write 2 here. write 2 here. So this salt, which is called sodium aluminate and which contains metal in its anion, so this makes aluminum oxide amphoteric because it can react with an acid to form salt and water. It can also react with a base to form salt and water. So zinc oxide and aluminum oxide are exceptional. They they form salt and water with acid as well as bases. So they are called amphoteric oxides. Now some oxides, they are soluble in water. Most metal oxides are insoluble, but some are soluble. They are called alkalis. For example, sodium oxide can dissolve in water to form sodium hydroxide. This is a combination reaction. If you can see, two reactants are giving a single product. Similarly, potassium oxide, calcium oxide, all these are soluble in water. If you see the reaction of calcium oxide with water, it gives you CaOH twice aqueous. So these are called alkalids, bases which are soluble in water. Then different metals show different reactivities with oxygen. For example, sodium, potassium, they catch fire at room temperature, even at room temperature. So we can say that these metals are very highly reactive. Magnesium, it catches fire only on heating. Then aluminium, zinc, lead, iron, they form oxide layer. They don't catch fire, but they make an oxide layer. There is a certain method called anodization or anodizing, in which aluminium oxide layer is formed on aluminium article. In this method, it's an electrolytic process. Dilute sulfuric acid is used as electrolyte. This actually we want water, but to make it more conductive, we add some dilute sulfuric acid into water. Then the aluminium article, which is to be anodized, is made anode. That means positive terminal of the battery is connected to that. So aluminium article is made anode. Then what happens? There is decomposition of water, electrolytic decomposition of water, and oxygen gas is released near anode, and that oxygen reacts with this aluminium, and thick layer of aluminium oxide forms on the aluminium article. And this method of forming a protective thick layer of aluminium oxide on aluminium article is called anodizing. So this anodizing can give aluminium article attractive finish. Also it can form a protective layer on aluminium article. The next reaction is reaction with water. So how do metals react with water? Metal react with water. Some metals like potassium, sodium, calcium and magnesium react with water to form metal hydroxide along with the evolution of hydrogen gas. But certain metals like zinc, aluminium and iron, they react with water to form metal oxides and hydrogen gas. So the alkali metals we have talked, they ultimately form that alkali. For example, sodium, when it reacts with water, so we can give the heading here, reaction with water. When sodium is reacted with water, it doesn't stop at the formation of oxide, but it ultimately forms its hydroxide along with the evolution of hydrogen gas. Again, you can see that hydrogen is odd here, 2 plus 1, 3. So we have to make it even by writing 2 here. So that will make 4 hydrogens, so 2H2O and here 2Na. So this reaction, general reaction, can be written as metal plus water gives you metal hydroxide plus hydrogen gas. Other examples of such type of reaction: calcium solid, when reacted with water liquid, forms calcium hydroxide, COH twice, aqueous, along with the evolution of hydrogen gas. So there are 4 hydrogen here, 2 oxygen, so 2H2O will balance this reaction. Now there is a slight difference between these two reactions. In the first reaction, when sodium reacts with water, hydrogen gas is produced, and along with that heat is also produced. That means this reaction is exothermic. Reaction with sodium is so exothermic that the hydrogen gas produced in the reaction can start to burn. But in case of calcium, although heat is produced, it is not sufficient to burn hydrogen. But in this case, calcium initially sinks into water, afterwards starts floating on the surface of water. And this is because hydrogen bubbles, they stick to the calcium metal, and by sticking them, they make it lighter. That means the density of that combination becomes less than the water, and then it starts floating on the surface of water. In case of aluminium, iron and zinc, the reaction stops at oxide formation because the oxides are not soluble in water. So if aluminium is reacted with water, and we have to write the physical state of water here gas, because they only react with water vapor and they do not react with liquid water. So Al plus H2O gives you Al2O3 oxide, which is solid in this case, not soluble as we have said earlier, plus hydrogen gas. So we have to balance it. 3 oxygens are there, so we have to write 3 here. That will make 3 hydrogen and 2 aluminium. Like that the reaction is there. Similarly, Fe solid, iron solid, plus water, again gas, reacts only with water vapor. Now this formula is Fe3O4. It's a combination of FeO and Fe2O3. So it is iron 2 oxide, iron 3 oxide, and together it makes the formula Fe3O4 along with hydrogen gas. Again we have to balance 4 oxygen here, write 4 here, write 4 here, write 3 here. So aluminium and iron along with also with zinc, they stop at the formation of oxide because their oxides are not soluble in water. So reaction of metals with water There are two types of reactions as we have seen. In one type of reaction, metal hydroxide is formed. In other type of reaction, metal oxide is formed. Then there is reaction of metal with dilute acids. Now acids have H plus ion as their cations. So here a displacement reaction takes place. So we'll write the heading, reaction of metals with acid. Reaction of metals with acids. Any acid for that matter can react with a metal to form a salt and evolution of hydrogen gas. So this is a displacement reaction in which a more reactive metal cation displaces hydrogen cation from acid solution. So the reaction can be, means we can write a general reaction, for example for hydrochloric acid, let us say, and magnesium metal, aqueous and solid, it gives you a soluble salt MgCl2 aqueous plus hydrogen gas is released, so 2HCl will make. Now there is an exception to this reaction, and that exception is of nitric acid. Nitric acid doesn't release hydrogen gas when it reacts with nitric acid. And it is so because nitric acid is a strong oxidizing agent. So as soon as the hydrogen gas forms in this reaction, it oxidizes hydrogen to water and itself get reduced, nitric acid itself get reduced to any of the oxide of nitrogen, N2O, NO or NO2, depending on the concentration of the acid. So nitric acid doesn't evolve hydrogen gas when it reacts with metal, but again there is one exception. Nitric acid can evolve nitrogen gas when it reacts with magnesium metal. Very dilute nitric acid can form magnesium nitrate MgNO3 twice plus hydrogen gas. The same thing happens when this nitric acid reacts with manganese. Now out of metals, magnesium, aluminium, zinc and iron, magnesium reacts most vigorously with acid, means the effervescence, the gas bubbles are maximum in case of magnesium, followed by aluminium, followed by zinc and iron. So it tells you about the reactivity of metals when they react with acid. So magnesium shows highest reactivity among magnesium, aluminium, zinc and iron, followed by aluminium, zinc and iron. So these are the three reactions that we have seen. We have first seen the reaction with air, that is oxygen, then reaction with water, and finally reaction with acid. Then the displacement reactions, means how do metals react with salt solutions of other metals. Displacement reaction. For example, if you have copper sulfate solution CuSO4 aqueous, when it reacts with a metal like iron Fe, that is iron nail is dipped into copper sulfate solution, it gives you FeSO4 iron sulfate along with deposit of copper on iron object. So initially the solution is blue and afterwards it becomes pale green because there is a chemical change here. Copper sulfate is converted into iron 2 sulfate, and this copper is deposited on the iron nail, so we get a brown color layer on the iron nail. Now this reaction, it depends on the reactivity of metal, means which metal cation can displace which metal cation. It depends on the reactivity. The most reactive metal is potassium, followed by sodium. Then we have calcium, magnesium, aluminium, zinc, iron, lead. Then there is hydrogen in between, which is not a metal but it can still form a cation, so we write it. Then copper, mercury, silver, gold, and finally platinum. Now in this reactivity series, if we have a more reactive metal, then it can displace a lesser reactive metal from salt solution, and that's why iron can displace copper from copper sulfate solution, because iron is more reactive. It comes earlier in the reactivity series than iron. But on the other hand, suppose if we have sodium chloride solution, and if we dip iron nail into that sodium chloride solution, then displacement reaction will not take place, because in this case iron is less reactive than sodium, so iron won't be able to displace sodium from sodium chloride solution. So these are the 4 types of reactions, the reactions of metals. So first we have seen the reaction with oxygen, means metal, how they react with oxygen. Then we saw reaction with water, 2 types of reactions, some metal form hydroxide, some stop at the oxide stage. Then reaction with acid, single displacement reaction, and finally the reaction with salt solutions of other metals, reactivity series.